Okay, guys, I'm going to do some some of the practice problems here on 6.3, simple interest. And we know we have this equation A equals P times 1 plus RT. This is our simple interest equation where we find the amount in this problem based off the principal, the rate, and the time. And in this case, we're investing $3,000, so that's our initial principal, and our rate is at 4.5%, so I'm going to put that as a decimal, 0.045, move the decimal over 2 places, and we're going to multiply that by 8. So 3,000 times 1 plus 0.05 times 8, that is going to be $4,080. Okay. Number 3 is the same kind of problem. We're looking for the amount based off the principal, the rate, and the years. I'll let you figure that one out. Number 5, we're trying to find the rate here. How much interest will a person earn? No, we're looking for interest here. Sorry. So how much interest will a person earn? So interest, the amount of interest is going to be, I'm going to call this capital I, is going to be whatever the amount is that you end up getting minus the principal, right? So this would give, the difference of this tells you, well, that's the amount of interest that you earn based off the rate and the amount of time. So we're looking at investing $2,300 at 3% for 49 years. Okay, 2,300 times 1 plus 0.03 times 49. We put that in our calculator and we get $5,681. Okay, so if this is the amount that we get and we started with 2,300, well, how much of this is interest that we accrued over the years? And that's just going to be the amount minus our principal here. So 5,681 minus 2,300, and that is 3,381 is our interest a person earns based off these conditions. What starting balance grows to 12,000, that's our A value, in 8 years with a 10% simple interest? Okay, so we don't know what P is. It's asking what the principal is. I'll put in parentheses. Okay. So 0.1 times 8 is 0.8. 1 plus 0.8 is 1.8. So I get 12,000 on the left. I've got 1.8 P on the right. And now I'm just going to divide 1.8 into 12,000. And the answer is, our principal is a lot of sixes. And it's rounded up. Okay, so that's the starting balance. That's the starting balance to grow to 12,000. Okay. How long will it take 1,000 to grow to 4,000 at 8% simple interest? We are asking for time. It takes to get to 4,000 if we start at 1,000. That's a 0. Those are supposed to be zeros. 0.08 times t. Let's divide both sides by 1,000. So I got 4 equals 1 plus 0.08 t. I'll subtract 1 to both sides. Now I'm going to divide 3 by 0.08. 3 divided by 0.08 is 37.5 years. Okay, suppose we have $1,500 and we want to have 8,000 in 15 years. What does the interest rate need to be? Okay, we're looking for R again. So R is what we don't know. We know T, we know A, we know P. 8,000, 1,500, 1 plus R times 15. Let's divide both sides by 1,500. 8,000 divided by 1,500. 5.3 repeating. One plus R. So 1 plus 15R. I'm going to write like that. So we're going to subtract 1. So I got 4.3 repeating now. And we're going to divide R to both sides. And I get 0.28 repeating. Okay, so we end up getting 0.28 repeating as our rate as a decimal, so we can say that's 2.89% interest rate. Okay, so 13, what starting balance grows to 2,500 in 2 years with a 1.5 simple interest? Okay, so we're looking for P in this case is our starting balance. And A is 2,500. 0.015. Not a very good interest rate here, by the way. Okay, so that's going to be... let's get my calculator. So 1 plus 0.015 times 2 has 1.03. Didn't even need a calculator for that. 1.03 P. And we're going to divide by 1.03. Let's get rid of that right there. Yep, so 2,500 divided by 1.03. It's not going to be much. 27.18. 2,000. 427.18. Okay, so that's what the principal would need to be. Okay, so a couple review problems here. Let's rewrite these exponential expressions here as logarithms. So 3 is my exponent, 10 is the base, and this is thousands what I get. So if I say log base 10 of 1,000, that would give me the exponent of equal to 3. Log base 10 of 1 over 1,000 equals the exponent -3. So log base 7 of 2401 equals 4. Log base 8 of 1/64 equals -2. Rewrite the logs as exponentials. Okay, so base 4 raised to the second power is 16. Base 4 raised to the -2 power is 1/16. I hope you see these are true, right? 10 to the 7th power is 10 million. I think that's 2.5. 2.5 raised to the second, yes, that's what it is 6.25. All right, I hope that was fairly easy. This one's a little more challenging. Solve the following equations. Check to see if you can write both sides of the equal sign with the same base. If not, you have to use a logarithm, okay? So 2 to the x equals 29. So can we write 29 as a base 2 expression? So 2 to the 5th, right? So 2 to the 5th is 32. 2 to the 4th is 16. So we can't, right? So we're going to write it as a log instead. So I could say log base 2 of 29 equals x, and then we could find what that is on our calculator. We can go log base 2 of 29. If you go to math on your graphing calculator and you scroll down, you can see log. It says log base. So this is about 4.86. Two to the x minus 3 equals 29. Let's add 3 first. 29 plus 3 is 32. And we just discussed that 2 to the 5th is 32 over here. So let's replace this with 32 with 2 to the 5th power. Right, so x has to be 5. Okay, number 11. Let's subtract 2. So I get 3 to the 2x minus 1 equals 9. We can write 9 as a base 3 exponent. 3 squared, right, is 9. So that means that 2x minus 1 equals 2. 2x equals 3. X equals 3/2. Okay. 5 times 3 to the x minus 1 minus 7 equals 127. Let's add 7 first. Let's divide both sides by 5. 130 divided by 5 is 26. Okay, we cannot write 26 as a base 3 exponent here. 3 to the 3rd is 27. I can't do 3 to the anything to 26. Okay, so let's write it as a logarithm. So that means log base 3 of 26 equals x minus 1, which is our exponent here, right? And then we're just going to add 1 to both sides. And if I pop that in the calculator, it's 3.97. It's rounded. Okay. Box this in too, I guess. Hope all that makes sense. I'll see you later.